Could this be evidence of another universe? For over 2 years, the James Webb Telescope has been uncovering the deepest secrets of the cosmos, revealing structures that, based on our current understanding, shouldn't exist in their observed form. As our existing models reach their limits, an intriguing theory gains traction, championed by British physicist and Nobel Prize winner Roger Penrose. He proposes that the Big Bang was not the absolute beginning but rather a dramatic transition between cosmic eras. Penrose firmly believes that the universe undergoes a continuous cycle of destruction and rebirth. Surprisingly, recent discoveries seem to support his theory. But what about the enigmatic Hawking points, which, according to Penrose, are remnants of a previous cosmos? While some experts speculate that the universe is infinite, from our limited earthly perspective, we can only observe a minuscule fraction of its vast expanse. Our spherical field of vision is appropriately referred to as the observable universe, and it encompasses the area from which information could have reached the Earth since the Big Bang. Given that the cosmic birth took place 13.8 billion years ago, one might think that the distance to our natural line of sight, the so-called event horizon, is also 13.8 billion light-years. 40 years, but that's not true after all. The cosmos, that is, space, has been continuously expanding since the beginning of time, which means that distances already covered have been lengthened retrospectively. The distance to the observation horizon is ultimately estimated at 46.3 billion light-years. What is exciting here is the fact that every point in the universe has its own observable universe. In other words, if there is a civilization billions of light-years away out there, it can see a part of space that will forever remain the great unknown to us. As a result of these cosmic blinkers, experts can only speculate about what lies dormant outside our field of vision. While many researchers believe that the structures there correspond to those in the local universe, others estimate that the invisible depths of space are much more bizarre than we can even imagine. However, the black hole that the James Webb Telescope added to the star charts a few weeks ago was also much more bizarre than we could have ever imagined. Christened with the scientific name Li 568, the gravity monster had already existed for 1.5 billion years after the Big Bang. But despite this, it apparently devoured matter 40 times faster than is theoretically possible. But let's be clear, this mysterious Webb discovery by no means marks an astronomical exception but rather corresponds to the new, confusing pattern we now know of a whole series of black holes that simply appear far too massive for their early formation. These include the quasar, an active galactic nucleus called J120+0641, which dates from the cosmic twilight era but already weighs over 1 billion solar masses. To the researchers' dismay, however, a closer examination with Webb's mid-infrared instrument, MAY, failed to reveal any extraordinary feeding mechanism. And so, it turns out that we simply don't know how a supermassive black hole could have been fully mature when the cosmos. The universe was only 5% of its present age, since our current models can no longer explain the cosmic premature babies of the observable universe. New approaches must be taken into consideration, and the fact that these sometimes have the potential to revolutionize our understanding of the universe is demonstrated by Sophie Kidman's remarks. Asked whether the surprisingly massive black holes could have formed from structures that existed even before the Big Bang, the astrophysicist from the University of Cambridge replied, "The exciting thing about this question is that nothing is ruled out. Some argue that the black holes we've discovered in the early universe must have formed through direct collapse. Numerous studies suggest that these observations support this theory. If black holes grow efficiently, they would have had enough time to evolve from a very small seed." However, while Kudmany highlights that this model is only one of many possible explanations, it presents a groundbreaking idea, that something existed before the Big Bang, and therefore, before our universe. For Kudmany, the cyclic model, the end as a beginning. The fact that current cosmology has reached its limits in many respects is also demonstrated by the Webb discovery, which triggered the astronomical crisis in the first place. After all, as early as February 2023, the news had already spread that there were 6 impossible galaxies out there that were as massive as the Milky Way is today, a good 13 million years ago. However, since this unexpected finding was in stark contradiction to our theories about the density of matter in the early cosmos and about galaxy evolution, the inexplicable objects quickly earned the nickname universe breakers. And apparently, some galaxies in the young universe were much more efficient at converting gas into stars than others. At least that was the conclusion reached by a research team from the University of Geneva, who studied 3 galactic heavyweights, also known as the red monsters because of their appearance in the Webb images. According to our theories, galaxies form relatively slowly within halos of dark matter. These capture atoms and molecules and bind structures around them with their gravity, from which galaxies ultimately develop. But while, as a rule, only about 20% or less of the captured gas is converted into stars, the corresponding proportion in the case of the red monsters is a whopping 50%. But once again, how the structures managed this some 1 billion years after the Big Bang remains an unsolved mystery in astronomy. For the time being, all we know for sure is that something must have happened in the earliest cosmic chapters that paved the way for the astonishing growth of galaxies. But what if that's not true? In other words, what if the foundation for the development of the universe was not laid with the Big Bang but before that? Well, then we would have. Roger Penrose, honored with the Nobel Prize in Physics in 2020 for his research on black holes, has put forward an astonishing theory that suggests the universe is cyclical. According to Penrose, the Big Bang was not the absolute beginning of everything but rather a transition between two cosmic life cycles. In this model, every end is followed by a new beginning. The universe would continue expanding until all matter has disintegrated into light. In such an extreme environment, where nothing has a time or space reference to anything else, a new Big Bang would inevitably occur, leading to the birth of another universe. As part of this cosmic cycle, black holes would also completely evaporate, leaving behind a special remnant that testifies to the existence of the previous cosmos. Penrose claims to have found exactly these telltale traces in the cosmic microwave background, CMB. Specifically, numerous circular spots observed in data from the Planck and WMAP satellites could serve as evidence for this theory. The CMB itself is a relic from the early universe, formed around 380,000 years after the Big Bang during the recombination epoch, and it continues to permeate the universe today. To understand the significance of discovering so-called Hawking points, we must first consider the cyclic model's proposition that cosmological inflation occurred before the Big Bang. In standard cosmology, inflation refers to a phase of extremely rapid expansion that happened immediately after the universe's creation. However, in the cyclic model, this inflationary phase is instead a result of the exponentially expanding future of a previous eon. From both a mathematical and physical perspective, the transition from one eon to the next appears sound. A key exception in this model involves supermassive black holes. By the end of a cosmic cycle, these black holes would have absorbed almost all matter from their surrounding galaxy clusters before they, too, evaporate into Hawking radiation. Crucially, the energy from this process would be carried into the next universe in the form of a single Hawking point. The photons produced in this event would spread outward and eventually become visible in the cosmic microwave background, leaving behind a potential imprint of a past cosmic era. The background radiation of the new cosmos is a fascinating subject. On paper, a Hawking point would appear as a disk the diameter of the full moon. In practice, the data analyzed has revealed exactly that in the microwave background. To be more precise, these ominous spots correspond to multiples of the average CMB temperature fluctuations. In fact, experts had assumed that such features would have been completely wiped out by cosmological inflation. In light of this exciting discovery and the many cosmological inconsistencies uncovered by the James Webb Telescope, an intriguing question arises: is it possible that our world does not correspond to a single universe at all, but only to the current cycle? This question lies at the core of an ongoing debate in astronomy, one that remains unresolved. Even if the universe follows an endless cycle of destruction and renewal, some key questions still remain. What, then, initiated this cycle? And does eternity even have a true starting point?